Hello fellow problem solvers. So they're going to be doing a problem from the Balkan Math Olympiad 2000, problem number 1. This is a nice functional equation. I suggest you try it out for a minimum of 20, ideally 45 to an hour, not more than 2 hours. If you'd like to go along with us, put your first ideas out on paper for the next 10 minutes. So now let's begin. What do we have? Final functions such that this is true. What do we do in such functions? Well, one thing is you can just plug stuff in, see what happens. It's from R to R. Let's plug in a 0, see what the 0 gives us. And that's one way to go about it. Another way of going about it is looking at, what do we have here? What do we actually have? And you can just go and plug stuff in if you want. I, for one, wanted to see, what do we have? We have a y here that's free. Right? It's free as a bird. And I now know from this y being free that this function is surjective. Why do I care about that? Well, maybe somewhere down the line I'll want to have an x such that something that's equal to something. That's why surjectivity might be cool. How do I know that? Well, if I set y to be equal to any z minus f of x squared, I'll have f of something, f of x, f of x plus f of z minus f of x squared. Doesn't matter f of what, but it's equal to z. And just like that, the function is surjective. You want to see if you have these sort of free-floating variables in general, and then just boom, surjectivity. Do I have injectivity? Well, I have f of y here. Is free floating. It doesn't have anything attached to it. Here we have an x f of x, so it's going to be more difficult. But given I have a free floating y, if I just set in x to be anything, if I have now, actually f of a is equal to f of b, what does that give me? That gives me that f of a plus anything is equal to f of b plus anything. And also f of that is equal to f of that. So f of anything being, say, x. F of x, I wonder why, plus f of a is then going to be equal to f of x f of x plus f of b, right? And why did I add this? Well, to have this on both sides. In other words, to have a equal b on both sides. I'm going to now have a plus f of x squared is then equal to b plus f of x squared. In other words, a is equal to b. Why do I care about injectivity? It might be important somehow, some way, shape, or form. Now that I have a function that's injective and surjective, that means it's what? Bijective. So I can now have anything that I want, right? I can have f of alpha equal to 0 if I want. Do I want it? I don't know. Here's where I invite you to pause for another 10 minutes and see if you can push the problem further. And here's the next step. So for me, I'm thinking, let me not just plug stuff in, see what happens. If I plug in a 0, x equals 0, I'll have f of y is equal to y plus some c, some constant some constant squared, where this constant is what f of 0 is equal to. Okay. If I plug in, say, y is now equal to 0, say f of 0 is equal to c. I plug in y is equal to 0, would I get anything cool? Doesn't really look like it. Hey, let's see. What I have, if y is equal to 0, I'd get that f of c is equal to c squared. It's something. And I can have an infinite number of these c's, but I'm not that interested in those. They're not going to give me really what it is I need and what it is I want, which is a solution to this function, which seems to be f of x is equal to x. Maybe there's another solution as well. So this is what I have from x equals 0, f of y. So if I have an f of something, I can get rid of it and get down to this. That's cool. Now let me see what happens when I plug in y is equal to 0. If y is equal to 0, I'll get f of x f of x plus c is going to be equal to f of x squared. Now I can't just cancel the f because, even though this is an injection, because it's an f squared. Like these could be two totally different values. Though maybe there's an f of something, there's an alpha such that f of alpha is equal to 0 because it's surjective. And if I set x equal to alpha, I'll get that f of c is going to be equal to 0. And now f of c is 0, f of alpha is 0. That means that f of c is also equal to 0, but it's c squared. So c squared is 0. In other words, f of 0 is equal to 0. And now this thing translates as f of x is equal to x for every single x. And this thing translates as f of x is equal to f of x squared. Now, what other number can I use, put in here to give me this, to use the injective property? For me, it's actually not that difficult. It's I want to have something that is a 1. Why do I want something that is a 1? I think because then this, if f of x is equal to 1, I get a 1 here. I was thinking like 1 squared, then the f, it doesn't matter that it's square, but I can get an injection, and that's just fallacious reasoning. But let's see what happens if f of some beta is equal to 1. Let's plug in x is equal to beta, and I have f of beta is equal to 1. I get nothing. That was a bit disappointing. I mean, if f of... yeah, I don't get anything. Man, that was disappointing. But anywho, here's where I invite you to pause for another 10 minutes and see if you can push the problem further. You have f of 0 now. What do you do now? You have f of x is x. You have this thing. Maybe is useful as well. What do you do here? Now's the time to pause, and here's the next step. So now we have this thing right here once we cleared up the board. And now we're thinking, okay, what is our next step going to be here? What are we going to do? How are we going to get closer to a solution? And the answer is I don't know. How are we going to get closer to a solution? Well, there's no use in plugging x is 0 or y is equal to 0 anymore, and anything else, because this is what we have from those. So let's look at these things more in depth, see what they give us. And this is a somewhat common thing to do. You have f of x is x. So sometimes you need to add an f to get rid of an f. You see where I'm going with this? We can here do one of two things. One is, we can say instead of x, let's put x is equal to f of some z. And then we'll have f of z. And then f of z is going to equal to f of z squared. Now, what is f of z? Well, this thing right here is z. And what is this? Also z. Oh, looky what we have now. F of z times z is equal to z squared. Right? Wait, but what is f of z times z? Oh, wait a second. That is f of x. That is f of z squared. So now we have f of z is equal to plus z or minus z for all z which are real numbers. Just like that. Now this is a bit worrisome, because I just thought that f of x is x was a solution. Turns out f of x equals negative x. This becomes x squared. You have a y, so that becomes minus y, and then f it again, you get a plus y, okay. A minus x, you f it again, you get a plus x. So, turns out both of these are solutions. And now are we done? Like there's only two solutions, f of x is x or minus x. There are two functions, right? Bye-bye. Okay, so as always, oh, we're not done? That is correct, we are not done. What could happen here? We've shown that for every function, for everything in the function, f of x is either going to be x or minus x. What if the function is plus x on some values, but minus x on some other values? what happens then? That could happen. We have not ruled out that as a possibility just with this. Everything we've done so far would still hold true. I mean, this would hold true, is what matters. I don't know if this would hold true. It's this, this could hold true. If, for example, every time x went to x, actually then nothing would happen. Every time x went to x, f of negative x would also have to go to x. And every time it went to a negative, the negative would have to go back to it. And this would be true. And I think so with this. Maybe we would have, if x is a negative, then its square would have to go to somewhere else, right? We still need to check that. And how do we check that this is not the case? Well, let's assume that there is some a and b such that f of a is equal to a and f of b is equal to minus b such that a times b isn't 0. Because we don't want the 0 messing us up here. 0 is both plus 0 and minus 0. It's 0 is all the way down. So with this in mind, I invite you to pause for another 10 minutes and try to push the problem further. And here's the next step. So let's see, we want to use this somehow. So let's say x is equal to a, yx. I get the value of this, and I get the value of this. I get two values right away. If I put y, I just get this, and then I have two more unknowns. What's happening? I don't know. So let's just put x is equal to a. And what do I have? I have f of a squared plus f of y is going to equal y plus a squared. Now, how can I mess this up? Well, if I get rid of a squared somehow, I can maybe mess it up here. What if I plug in a b now? If I plug in y is equal to b, what will I get? I'll get f of a squared minus b is equal to b plus a squared. And now this thing right here, what is it equal to? Well, it's either equal to, it's either equal to a squared minus b. In which case, if this was true, then these two things combined would imply that b needs to be 0 because the a squared would cancel out. A contradiction, mind you. And if it was the negative, if it was b minus a squared, then these two things would imply that a squared is equal to 0. In other words, a is equal to 0. Another contradiction. So there can't exist a and b such that f of a is a and f of b is minus b at the same time. That's why this is a little bit of a tricky problem. You need to make sure that you know what this function has led you to. Right? It's given you that this or this is true for every z that you plugged in. But it hasn't told you that all of it is only this or all of it is only this. It's a thing that comes up sometimes in functions. Be aware of it. Another way of, instead of saying if f of a is plus this and minus, we could have also said take a value, say f of 1. If it's 1, we could prove that everything else is going to be plus a. And if it's minus 1, prove everything else is minus a. So that's a different way to go about doing this. This finishes up the problem, and as always, thanks for problem solving.